Welcome back to ECE 207. Have to remember which class I'm in. All I have to do is look at the board, right? Read the notes. ECE 207. The homework is due today. You'll have another homework due in a week. That should be available on the D2L website. And the material that you should be reading to stay up to speed on what we're talking about during the lectures today and the next week will be chapters 2 and 3. That will really be covering the material, I believe, for the first exam, chapters 1, 2, and 3. What we want to do today is, maybe we don't have to, did everyone go home and figure out how to do the voltage divider problem? We'll talk about that today. I didn't see too many rapid hands go up. We'll talk about the voltage divider, or how to develop that expression, the current divider, and we'll begin talking about node voltage analysis. That's our plan for today. Voltage divider and current divider. Let's talk about the voltage divider first, which was the circuit that we stopped with last time. Was the question, what is V sub 1 in terms of the R's and the source voltage V sub S? Or was it V sub 2? Was it V sub 3? It really doesn't matter. It can be any of those. The expression will obviously be different, but the structure will be the same. And what we're wanting to answer is, how is, let's say, this source voltage V sub S, hopefully now it makes sense, or you get a feel that V sub S is going to be split or divided across those 4 resistors. It's going to depend on the value of those resistors as to how much voltage is dropped across each of those resistors. But how is the source voltage V sub S divided among the 4 resistors? Or you could think of those as loads. If somebody asked you to analyze that circuit, how would you potentially analyze it? You're given V sub S, you're given R1, you're given R2, you're given R3, and you're given R4. What is there to know, or what is a key variable that, if you knew it, would help you figure out a lot of the answers that maybe you're asked, the answers to the questions that you're asking? What's an unknown that if you knew it, it would really help you answer some questions? The current, correct? If we knew the current, because everything is in series, the current's the same, we can now say, oh, if somebody knew that current, we could then find that the voltages that we might be interested in. We could find V1, for example. We could find V sub 2. Based on Ohm's law, correct? We could find V sub 3, or we could find V sub 4. All of those could be determined once we had I. Let's find I. One approach. Those resistors are all in series. Let's then find their equivalent. If we know the equivalent resistance, then we can divide that into the voltage that's being supplied to the entire circuit, and we have our current. If we can find our equivalent, and we learned that last time, those are all in series. Consequently, the equivalent resistance is the sum of all four of those resistors. If that's the case, then this I that we were interested in is just V sub S over R equivalent. And if that doesn't make sense, I would suggest that you redraw the circuit and have V sub S in series with R equivalent and say, okay, what is the current through that series or through that loop or in that mesh? There is I. If we know I, as we indicated before, we should be able to find any of those voltages. Let's just find V sub 1 for starters. By Ohm's law, that's the resistance times that current I. Or, let me now expand R equivalent into what it is in terms of the R's, and we have R1 all over R sub 1 plus R sub 2 plus R sub 3 plus R sub 4 times V sub S. I've just factored that out a little differently, where I did have Vs divided by R equivalent. I had to multiply it by R sub 1. Let me just group all the R's together and factor out the source voltage, V sub S. That's the expression I was hoping you would come up with at the end of class last time. There's V1 in terms of the R's and V sub S. How do you see that formula? Well, you see that you needed all of the resistors in the bottom, and that basically, when divided into the voltage, gives you your current. And then whichever voltage you're interested in, the voltage drop across R1, R2, R3, that will depend on what's in the numerator. If you're interested in the voltage drop across R1, you just R1 times I. And so R1 is in the numerator. Meaning, now you have the generic formula V sub I is equal to R sub I times I. Those I's mean different things. Hopefully that's clear. That's not V sub current. That's just V, the subscript I. Maybe I shouldn't have done that. Maybe I can change that. Whoops, that was supposed to be an L. You didn't see that. There, I did better. Penmanship. R sub L times I, where we now have R sub L all over R1 plus R sub 2 plus R sub 3 plus R sub 4 times V sub S, where L is any of those values, 1, 2, 3, or 4. Questions on that? That's the voltage divider. That's how the source voltage will be divided among those four loads or those four resistors. Is simply the source divided by all of the impedance or all of the resistance, and then you scale it by whichever resistor you're interested in finding its voltage. Questions? How many got that answer? Good. Well, that fraction should improve by exam 1, because this may just be a part of a question on exam 1. Won't be that much of a gift probably by exam 1. Current divider. Let's look at a common situation. Here's a current divider situation. And this is actually going to be a part of homework number 2. And it does have a physical application. R1 might be your body, and R2 might be a drill. And you hope that most of the current goes through the drill to ground and not through you to ground. And so you're designing the ground resistor so that you minimize the amount of current flowing through your body, because we know based on the Berkeley students that we can only tolerate so much current going through our chest and messing up with our heart, right? Don't want too much current flowing through our body. And what are we? We're quite a bit of water, aren't we? So we don't have that high of a resistance, especially if we're nervous and our hands are sweaty. Then there's a good conducting path right through our body. If we have dry hands, that helps. So if you ever grab something, make sure you're not sweating, okay? Sorry. You don't want to be grabbing anything. And if you do, how do you do it? One hand in your back pocket, correct? And just point with one finger. Don't get both of them down there in the mix of things. Where were we? Oh, current divider. We have a source current that's supplying those two resistors. Some current of that I sub S is going to go into R1, some is going to go into R2. What's your intuition tell you? If R1 is bigger than R2, how are I1 and I2 related? So if R1 is bigger than R2, I1 is bigger than I2. No, the other way around, right? Resistance is resisting current. R1, if it's bigger than R2, then you would expect I1 to be less than I2. Is that clear intuitively? Let's derive the result. In this case, we're given a current. If somebody could find that voltage, we would be done, because we know Ohm's law. V times R is equal to I, or I is equal to V over R. If we know the voltage and we know the resistance, we can figure out what current is flowing through that resistor. We want to know what is I1 or I2, and now we've learned to anticipate that if R1 is bigger than R2, I1 should be less than I2. That's what we are expecting. And it's always nice to anticipate the result. And on an exam, if you had 30 seconds left and you came up with this problem, you might write that down. You might say, A, find V, B, compute I sub L. Hand in your papers, please. At least you would get some credit. Correct? At least I know that you understand how to solve the problem. If I just would have had another minute, I could have solved it. That's fine. You didn't have another minute, but at least you wrote that down. You told me you knew what was going on. Good. How do we find V? Now that I've scrolled the circuit off, half off, use your how do we find the voltage drop? Or what's one way? If we're trying to find V, what did we talk about last time? R equivalent, right? How do we find the equivalent resistance? If we knew how to replace R1 and R2 with their equivalent, then we could find V pretty easily, because we know the current flowing through that equivalent resistor. And the equivalent resistor is the inverse of the sum of their reciprocals, Or maybe you've now learned or remembered that it's the product over the sum, and that you can find just by performing some algebraic steps on the first formula. If we now have that to replace R1 and R2, our circuit now becomes something like this. And we can now find V. What? I don't know why I'm making mistakes, because I don't want to use the eraser. It takes forever. Am I done? Almost, aren't I? I'm almost finished. I'm almost there. If I want to find now I sub 1, how do I find that? I1 is the current through R1, and I now know V. I apply Ohm's law, correct? I know the voltage, I know the resistor, I can find the current through that resistor, V over R. V I just computed, and the current I1 is going to be determined by dividing V by R1. If that's the case, if I now replace this V with the green V, there's a current divider expression. Likewise for I sub 2. That's V over R sub 2, which is 1 over R sub 2 times this equivalent resistance, which is now R1 over R1 plus R2 I sub S. Which says that now our current divider, if we have two resistors, we need to sum both of those resistors, and then to find the current through I1, we look at the other resistor and put it in the numerator and multiply by I sub S. Meaning we grab the opposite resistor and put it upstairs, put the sum downstairs, and multiply by I sub S. In this case then, if R1 is bigger than R2, I2 is going to be bigger than I1. Does that make sense? Which is what we anticipated. Questions on current divider and voltage divider? Let's then move into node voltage analysis. And the hint that I would like to suggest is that you should study now it turns colors. Oh well, I'm not going to turn back. Study and understand the blue marginal nodes in the chapter or in this section. Those are sort of guiding you through the process or helping you learn this technique or techniques, and so pay attention to those. In terms of the process that we're going to use, the analysis process for node voltage analysis is presented on page 74 of the textbook. Oh, and that's edition 4. And I've tried to include the problem statements on the D2L website. If you're having trouble with your particular textbook edition, hopefully that will help. Okay? If you have a newer edition or if you have another kind of edition. Let's look at nodal analysis. Example 1. Come on. Say that first source is a current source on the left, I sub A. Let's say this other source is also a current source. Let's call that I sub B. We'll label these resistors from left to right. Here's R1 vertically, R2 horizontally. The next resistor vertically is R3, R4, R5, and R6. And we want to find all the important information about that circuit. We're given I sub A and I sub B, and we're given the resistor values. We now need to figure out what else we need to learn about that circuit. Here's the approach that we're going to use. First, identify the nodes. Once we've identified the nodes, we'll assign node voltages according to how we've selected the nodes or defined the nodes. And that will become a little more clear in a minute. Once we've assigned node voltages, we will apply after I think a while. I'm losing patience. Apply KCL at each node. And then let's rewrite the equations in a standard form. Let's start identifying nodes. How many nodes do we have in that circuit? How many vote for 2? 3? 5? Let's start counting. There's a node. Correct? How about this one? That's a node. How about this one? That was supposed to be the third node. That's a 3. That's supposed to be a connection. There's 4. So is this 5? Oh, you can't see me pointing, can you? Can you see my cursor? How about that for 5? Is that okay? That one is shared by many, many more lines, and so that one we'll probably call our reference node. We use one of those nodes as a reference node, and a lot of times the way the circuits are sketched, that reference node ends up at the bottom and it may be labeled the ground node. In nodal analysis, that's the one that we will be assigning our negative polarity to, and all the other points or nodes will be given a positive polarity sign from that reference. Meaning, here, to be consistent with the way that we've labeled the nodes, let's call this V1, which is the voltage dropped between node 1 and that reference node number 5. If you took a voltmeter and put it across those 2 points, you would measure V sub 1. Here's V sub 2 across node 2, so you'd put the positive terminal of your voltmeter and your negative, or usually red and black, you'd put your red lead on the positive side, node 2, your black lead on node 5, and measure V sub 2. That would be the voltage dropped across R sub 3. Then we could have V sub 3. The voltage dropped across that current source. And V1 is also the voltage dropped across I sub A, isn't it? Because I sub A is in parallel with R sub 1. And we finally could think about this particular voltage drop. I have a magic act, and I'll do that after class, when I've had a minute to catch my breath or to take some deep breaths. Pretty soon this computer may be flying up into the audience. So if you're interested in a computer, get out your gloves or your soft hands and make a good catch or make a grab. Hopefully that will happen tomorrow night, right, for the correct team? Is that what I was told? I don't know. Not supposed to be dating these lectures. I just did. V sub 4. Actually, if we wanted to do a lot of math, we would label all of these nodes, 1, 2, 3, 4, and 5. But if we want to simplify our life sum, we might say, you know what, R5 and R6, those are in series. Let me just find an equivalent resistor, R5 plus R6, and that's now going to drop the same voltage as V sub 3. Does everybody see that? What we will find, and now I can't remember what I did actually do. Let me look at my notes. Okay. I did actually just combine these, meaning I'm going to just combine these into one equivalent resistor, and I'm going to call that R sub 5 bar when I'm given the chance. Okay. Does everybody understand what I'm doing? And that will actually eliminate the need for V sub 4. What you will find is however many node voltages you've created in an all-resistor diagram, you're going to end up with, in this case, if I had 4 node voltages, I would end up with a 4x4 matrix I need to invert in order to find my answer. Maybe you want to do a 3x3. That's what I want to do. And so I effectively reduced that fourth node voltage, I collapsed R5 and R6 into one equivalent resistor, which I'm calling R sub 5 bar. Question?
Just a question on the notation. In ECE specifically, what does bar refer to? Just a equivalent or what?
It's a great question. The question was, what's bar? I don't know. It's a bar. It's just another variable. Does that help?
It does.
Where it's nothing in particular, it's just a different variable. I could have made it a hat. If you like hats, put a hat on that. Okay, if you like tildes, put a tilde on it. It doesn't really matter. As long as you're clear that that's not R sub 5. I'm trying to distinguish that from R sub 5. Now, oh, I see what you're getting at. Is it a phasor? Is it a vector? Maybe later a bar will mean something. I'm sorry, I didn't pick up on your question. Okay? So it might end up being, oh, that's an RMS voltage, or that's something else. It's a phasor. We haven't gotten there yet. Right now we're dealing with resistive networks. And in this case, hopefully it will be clear by context what the bar means. Does that help? And the other thing is this bar is on a variable, or a parameter. It's not really on a voltage or a current. When the bar gets placed on a current or a voltage, then it might mean something. Just like a RMS value or a phasor. But now what I've tried to do is simplify my life and only force myself to do a 3 by 3 matrix. Now I have three unknown variables, V sub 1, V sub 2, and V sub 3, instead of V1, V2, V3, and V4. All right. Now let's read our red notes. We've identified the nodes. There were 5. We basically reduced that to 4 now. And one of those 4 was a reference, so now we have 3 node voltages. We've assigned node voltages to the nodes. Now let's apply KCL at each node. And we all know how to do KCL because of homework 1, right? What do we have at I sub 1? Let me try to draw something. I'm getting a little bit nervous about this, so I hate to even hardly do anything. Which way do I want to label those? Suppose I do that, and underneath that hourglass is a 2. That's I sub 2. It disappeared. Magic. It will come back, I hope. Then I could not record the lecture. Sorry. Yes, so I'm making this crazy thing do too much. I need to get a better system. Okay? All right, there's I sub 1, I sub 2, and that other black arrow is actually I sub A, isn't it? It's the same current. I want to do now KCL at node 1. You thought I was listening to something in my ears, didn't you, with that Windows Media or something, while I'm lecturing. Yeah, that would be magic. Then I might say, never mind. So I sub A, KCL, in equals out, correct? And I sub A was going in, I1 and I2 were both going out. If we just do it that way, I'm almost tempted to close it up and say I'll do it on my own. But there's I sub 1 plus I sub 2. What is I sub 1? Do you remember? You have it in your notes. And maybe I will do something else another day too to give. What is I sub 1? Ohm's law, right? And we know it in terms of V1 and R1. This is V1 over R sub 1, right? What is I sub 2? Let's go back somewhere. Deep breaths. There it is. If we now have this as, let's say this is plus V sub R sub 2 minus, what would I sub 2 be? If we knew V sub R sub 2, let's just assume we knew it, then what would I sub 2 be? Does everybody see what I'm doing? Here's what I'm trying to do. Is frustrate everyone. Here's my circuit, sub-circuit. This node was V1. This node was V sub 2. This was R sub 2. Here is I sub 2. That's what I have, correct? Up above, this is just, I'm pulling this out and this is what I'm thinking. There's V1 on the left, V2 on the right, R2 between those. I can find I sub 2, that's just V sub R sub 2 over R sub 2. Does everybody see that? But what I want to do is I need to write my equations in terms of V1, V2, and V sub 3. I need to find V sub R2 in terms of V1, V2, and V3. Can you see how I might do that? Remember, this is basically the reference. This was maybe a resistor over here, and here was a resistor over here, but that doesn't really matter. We know that that left-hand node was V1, the right-hand node was V sub 2. We know the voltage drop around that little mesh, we can apply Kirchhoff's voltage law in that particular sub-circuit. We can walk around this way. We can say then that minus V1 plus V sub R sub 2 plus V sub 2 is equal to 0. That's by KVL. Are we okay with that? From that we can solve for V sub R sub 2 to obtain V sub 1 minus V sub 2. And that's what we wanted. We wanted to express V sub R sub 2 in terms of V sub 1 and V sub 2. And now we have it. We can now say that I sub 2 is equal to V1 minus V sub 2 over R sub 2. What we had to begin with was that I sub A was equal to I sub 1 plus I sub 2. That's just V1 over R1 plus V1 minus V2 over R sub 2. And that's equal to I sub A. And there's one equation in the three unknowns, V1, V2, and V3. If we wanted to write that in a standard form, I would say, okay, give me the coefficients that multiply V1. Put those in front of V1. All the equations that multiply V2, group those together. All the coefficients. All the coefficients that multiply V sub 3, and then all of those equal the sources on the right. In that sense, I have 1 over R1 plus 1 over R sub 2 V1 minus 1 over R sub 2 V2 plus 0 V3 equaling I sub A. And that's a standard form that we could write it in. If we go back to our circuit, which I'm not going to scroll back to, I'm going to just redraw it and hope that my memory is somewhat there. Let's say this is now V sub 2. Here is V sub 1. And here is V sub 3. I'm just pulling that piece out of my original circuit. This was R sub 2. This was R sub 3. I hope this is correct. Let me go back in my notes. And this is now R sub 4. Does that look correct? And let me just assign some new currents. I can define currents as often as I want. Suppose that I say for this node, this was node 2. Let me call this I sub 6. This let's call I sub 3. And let me call this I sub 4. I'm trying to write KCL for node 2. And I can do it in terms of those currents that I've presently defined. And all of those are flowing out of node 2. I can say all of those must sum to 0. KCL at 2 says I sub 6 plus I sub 3 plus I sub 4 is equal to 0. What is I sub 6? Based on what we learned for finding V sub R sub 2 before. If we look at, we want the voltage drop to be positive from node 2 to the left. We would like to define a positive voltage from node 2 to the left. That would be V sub 2 minus V1. Does that make sense? If you go back to what we did just before, we were trying to find I sub 2 going to the right. And that was, we look at where we are now, which was at V sub 1. We subtract the voltage where we're going, which was V sub 2, and divide it by R sub 2. Now we want to go the other direction for our defined current I sub 6. For I sub 6, we say, oh, for that to be positive, going that direction, we need a positive drop across R2 from node 2 to node 1. A positive drop across R2 from right to left says it should be V sub 2 minus V sub 1. Is that making any sense? I sub 6 is now V sub 2 minus V1 over R sub 2. If you don't like that, define an arbitrary voltage again. You could say, let me just call this plus V sub R sub 2 bar minus. Oh, I don't like that bar, so let me make it a tilde. How's that? That's a pretty bad tilde, but you can do better, okay, in your notes. Then you could do KVL around that little loop to find what V sub R sub 2 is, and hopefully you would find that that's V sub 2 minus V1. Does that make sense? What's I sub 3? We're trying to write these in terms of V1, V2, and V3. What's I sub 3? Ohm's law. Does that make sense? What about I sub 4? Use the same strategy we just did or used to find I sub 6. Where are we starting? We're starting at V sub 2, aren't we? We want I sub 4 to be positive going to the right. So we now want the voltage dropped across R4 from left to right to be positive. That means it's V2 minus V3. So we have V2 minus V3 over R4. Questions on that? And now we need to combine all of those.
Why is it V2 minus V3 and not the other way around?
Why is it V2 minus V3? We want to know if I sub 4, so the question is, why is it V2 minus V3? We want I4 to be positive going to the right. By Ohm's law, R4 times I sub 4 needs to give us a positive voltage. That means if we labeled it with the passive sign convention, I'd have a plus on the left of R sub 4 and a minus on the right, correct? So I would say here's plus V sub R sub 4 minus. Now let's just do KVL around that particular path, if I can do that. Oh, I forgot to put in my plus sign for V sub 2, but now let me come up here, go there, and come back down to that point. If I do that, I have minus V2 plus V sub R sub 4 plus V sub 3 is equal to 0. V sub R sub 4 ends up being V sub 2 minus V sub 3, and this, I think, is what we wanted to show. Does that make sense? So what I want you to do, if you can't see it right away, that's fine. What I want you to do is get comfortable with that process, and pretty soon you'll get very comfortable with just saying, oh, I want I4 to be positive going to the right. That means I do V2 minus V3. Is that making sense?
Yeah.
Question?
Why did you define V sub R2 and V sub R4 in different positive and negative terminals? You just defined them in relation to the direction of current?
So the question was, why did I have V sub R4's polarity going positive left to right and V sub R sub 2 tilde, boy, that's a mouthful, from right to left positive? Correct? Was that the question? And you answered your own question, I think. You said, oh, you want the currents to be positive in the direction that you've sketched them. If I sub 4 is to be positive to the right, which it may not be, it may end up being negative, but everything would take care of itself as long as you obey your signs. But if you now say I sub 4 needs to be positive to the right, then I need a positive drop of R4 from left to right. Likewise, if I want I sub 6 to be positive to the left, I need the positive voltage to be from right to left across, wherever I am, R sub 2. Question?
In other classes, like the method for going to these circuits, we'd start by labeling positive and negative to all the resistances. Is that okay? As long as you follow that scheme.
The question was, can we initially assign polarities, and then stick with it. I did for my node voltages. Then what I did is sort of on the side, on another sheet of paper, so to speak, I started needing some help. I needed some guidelines. That's why I created these V sub R sub 2 tilde, and I labeled them the way that I did. But those wouldn't even have to be there. I could just erase those. But I'm using those to convince myself that the polarities and the algebra that I need to get the voltages that I want in the numerators, I wanted to convince myself that those were correct. So that's the reason why I created all these different voltage drops in that circuit. It was really just to convince us that it's true. It's not that we need to leave them there or that they even need to be there. What we need to have are the node voltages, the V sub 1, the V sub 2, and the V sub 3. We define those. Let's live with those. That's how we're defining or writing our equations. Question?
Is it okay to, I mean, it's on that same note, so like, it's okay to change the direction of the voltages every time for each node as long as you only do it for that one? And here, you've got all the currents going out, and you know that some of them are going to be negative. Is that okay to just assume every time? Like,
So what we're doing is we are writing KCL at each node. So the first thing we did was we labeled our nodes, or found our nodes. We labeled those with node voltages. Then we wanted to write KCL. We are now labeling some currents on the diagram that we're doing just for bookkeeping purposes, just to keep us organized. What we may do on the next node is draw another current going from right to left through R sub 4. And that's okay. It's going to be the negative of I sub 4, but it's easier, I think, to just do it now and then forget what you just did and worry about the next node to write the KCL at the next node.
But then your equations can't mix.
These equations will eventually be able to mix, because as long as I end up with equations in terms of V1, V2, and V3, and my R's and my I's, as long as I don't change the signs on V1, V2, and V3 halfway through the problem, I'm okay. And I haven't changed those signs at all.
You change the direction of current.
I've changed the current direction that I'm looking at. Well, I shouldn't be scrolling. Just to derive my formulas or my equations. But I really haven't changed V1, V2, and V3. It's just that in this particular case, for node 2, I'm wanting to find the current going to the right through resistor R4. And if there is a current going to the right, and if it is positive, then it's going to be V2 minus V3 divided by R4. If V2 minus V3 ends up being negative, it's taken care of. And we realize actually that I4 was supposed to be going the other way, but that's okay. It will all come out in the wash as long as we do not change V1, V2, and V3's polarity partway through the analysis of the problem. Those are the ones we need to keep fixed. But we are going to introduce new currents during the process. That's what's, I think, bothering you right now. And that's okay to be bothered, but we need to make sure you start to feel comfortable with it eventually. Where were we? Oh, I still haven't finished this. Now we need to combine all of these, but now we have I sub 6, I sub 3, and I sub 4 all in terms of V1, V2, and V3. Is that clear? And I can now write down an equation. I can say that I have V2 minus V1 over R2 plus V sub 2 over R sub 3 plus V sub 2 minus V sub 3 over R sub 4, all equal to 0. How many equations am I trying to find? How many have I found so far? I'm going to say this is one. Did I already write another one? How many nodes do I have? How many node voltages do I have? V1, V2, V3. I should be finding 3 independent equations so that I can solve for those 3 unknowns, V1, V2, V3. I wrote one equation by writing KCL at node 1. Here I found another equation by writing KCL at node 2. I now need to find one more equation at node 3 and write KCL. What I am doing, though, is I'm converting this maybe into a standard form. That's not a new equation, it's just another way of rewriting this, and it's equivalent to this particular formula. And the standard form is going to be collecting all of my coefficients that multiply V1 all of my equations that multiply V2 and all of my equations that multiply V sub 3. I have just erased half of my lecture. Actually all. This was the very first circuit. That's the voltage divider. Just don't do, what? You're having too much fun. That's yesterday's lecture. Here is today's lecture. Whoops, this was a current source, wasn't it? Because it's not on my computer anymore, I've lost it. It's in your notes. I think that's the correct circuit. And we found, or labeled, V sub 1, V sub 2, and V sub 3. So if you're on the right side of the classroom, you aren't going to be left out. How's that? Easier technology. We now want to write our KCL at that node. Here's node 3. Here was node 2, and here was node 1. KCL at 3. And now what I'm going to do is just define some currents, just so that I can keep track of what's going on. Now I'm going to define something that's maybe different than what I had before going through R sub 4. That doesn't matter at this point. I'm just going to define it. Here is I sub, let's say, 5. And this one coming up in my source is I sub B. Meaning, now KCL for this particular circuit is, how do I want to write it? Question?
Change back to R sub 5 bar, so you've got the equivalent.
So this is going to be R sub 5 bar. Is that okay? So I'm going to replace R sub 5 and R sub 6 with R sub 5 bar. Question?
I'm a little confused on what the difference is between the node voltage and the voltage going through the resistors at where you have the wire.
Now are you asking what's the difference between V1 and, let's say, this voltage V sub R sub 2? Is that what you're asking?
Yeah, or for example, VR3 or VR3 V2 is the same.
So V sub 3 and V sub 2 are different. What were you asking?
Well, okay, so V sub 1, V sub 2, V sub 3 are the node voltages.
Correct. We're trying to find V1, V2, and V3. Those are our node voltages.
So resistors R1, R3 will also have voltages going through them.
R1, so R1, R2, R3, R4, R5, bar, those all have voltage drops across them. They have current going through them.
So is the voltage drop V1 and V2, are those the same as the voltage drops that's going through R1 and R3?
So
Like, I know
V,
you wrote that before, but what exactly?
V sub 1 is the voltage dropped across R1. It's also the voltage dropped across I sub A. V sub 2 is the voltage dropped across R sub 3. So if we needed to find that current through R sub 3 coming down, it would just be V sub 2 divided by R sub 3. V sub 3 is the voltage dropped across that current source. So if V sub 3 is positive and I sub B is positive, if it comes out that way, what do we know about that source, current source? Is it absorbing or supplying or delivering power? If I sub B is 2, that was, we don't even know, it was a given. I sub B is a given current source. If I sub B is 2 and V sub 3 ends up being 7, is that current source delivering power to the rest of the circuit? Is it supplying power or is it absorbing power? This is on your homework, either today and maybe next week. 50-50 chance, right? Flip a coin. Supplying or absorbing? Which one is it doing? Which way is the current coming out of the terminal? Is the current going into the positive terminal as we've labeled V sub 3? Our passive sign convention says if our current is going into a positive terminal, it's absorbing power. Now if it ends up being negative, being absorbed, so if it ended up being -6 being absorbed, it's actually delivering or supplying 6 watts of power. But in this case, if I said whatever I said, I sub B was 2, and did I say V sub 3 was 7, both positive, then there's 14 watts being supplied to the rest of the circuit because the current is coming out of the positive terminal. It's not going in. It's not being absorbed. It's being supplied. It's supplying power. Yes?
I think what I should ask is, could you pick the voltage or the voltage drop for node 2 to be across R2 as opposed to R3 and still get the same answer?
Okay, so the question is, can we pick the voltage across R sub 2 and still get the same answer? And the answer is no. So what did we do? We found our nodes, and we then we said, what's our reference node? And that was the one with the most wires sort of connected to it. That was the bottom. Let's call that the common node. That's our negative terminal. Relative to that, let's go to each of the other nodes. That's how we picked V1, V2, and V3. If we need to know the voltage dropped across R2, you could say, okay, which way do you want it to go? How do I want to hook up my voltmeter? If I put my positive lead on 1 and my negative lead on 2, I'm measuring V sub R sub 2. And that would be V1 minus V2. If I needed V1 minus, if I knew V1 and I knew V2, which is what we will find eventually, then we could find what the voltage dropped across R2 is from left to right. Is that making any sense? Where were we? KCL at 3. Or I can go back to yesterday's lecture, apparently. Wow. KCL at 3. I sub 7, that's going out, isn't it, of node 3. Is there anything else leaving node 3? I sub 5. Is anything else leaving node 3? I sub B is leaving with a minus sign. We could do it that way, couldn't we? Or we could say it's coming in, so it equals I sub B. It's whatever we want, however we want to do it. We could say I7 plus I5 is equal to I sub B. Is that okay? Now we need to find I sub 7. What is I sub 7? Are you starting to get the feel for how to define I sub 7? That needs to be, we need to define it in terms of V1, V2, and V3, and we want it to go to the left, a positive current going to the left. How would we write that? Does everybody see that now? That's, I hope, what we've learned from today. What about I sub B? That's a given. That's a given value. What about I sub 5? What is I sub 5? Remember now, we've replaced R sub 5 and R sub 6 with one resistor, R sub 5 bar. What is I sub 5? What's the voltage dropped across R sub 5 bar? V3, right? It's easy, so it's hard. All of V3 is dropped across R sub 5 bar. So this is then V sub 3 divided by R sub 5 bar. Does that make sense? And now we can finish that equation. We now know that V sub 3 minus V sub 2 over R sub 4 plus V sub 3 over R sub 5 bar is equal to I sub B, and I sub B was a given. And that's our third equation. If we wanted to write that in standard form, we would have 0 times V sub 1 minus 1 over R sub 4 V sub 2 plus 1 over R sub 4, plus 1 over R sub 5 bar V sub 3 equaling I sub B. Questions on that? Does everybody remember their code number? Any questions on this? All right, we're ready then. Take out a piece of paper and analyze this. Wasn't that a movie? Yeah. So analyze this. I haven't seen the movie, so I don't even know if it's appropriate. Here's your circuit. Whoops, can't see. So there's an R4 down in the bottom right.
You said analyze the
What do I want? So that's part of the question, actually. So the question was, analyze the circuit. Now I'm wanting you to struggle with that and say, what in the world does he mean? What does it mean to analyze the circuit? What I'm wanting you to figure out is, what do I need to do? Because if you do it now, hopefully it won't be such a struggle come exam 1. I want you to struggle with it now when there's not as much on the line as if I ask this on the exam and you go, what's the question? And I'd say, I can't help you. So now, what does it mean when I say analyze the circuit? What are you given? Maybe I should just be quiet, but you're given a circuit with R's and a source. What do you need to find? Should I give you any more help? What did we just talk about? What were we just doing? We were doing nodal analysis. Can you perform nodal analysis on this circuit?